Hello everyone, I hope you're safe. I apologize for the delay, just some connection problems, you know how the internet is these days. Anyway, welcome back to the fourth session in this live series about the 12 factor apps. Let me know if there are any problems hearing my voice or seeing the screen or seeing me, for now at least. Anyway, throughout the way, just let me know if my voice is not clear, or if things are slow. I'll try to work on them. But for the time being, let's jump right into it. So in the previous sessions, we spoke about a couple of factors from the 12 factor app, and today we'll be discussing some more. Today's session is not that long, actually. We'll be discussing two factors, one of which is the backing services. And what I mean by backing services is that whatever 12 factor app that we're building should assume that any service that it needs or relies on is a resource that is connected to it. And what I mean by a resource is that it's like a service running somewhere. The app doesn't really care about where that somewhere is. It could be like local on the same machine, or on some other service or server running on a totally different place in the world. As long as the app knows how to connect to this resource or service, it doesn't really care how this service is operating. So, and this is what I mean by backing services, as in backing the app to work. So, as I said, a backing service is just a service that is consumed over the network. This is like the keyword here. So the service that the app needs to be available over the network. And examples of these could be like the Postgres data store or database server that we worked with the last session, messaging or queuing systems such as RabbitMQ or Beanstalk, binary asset services such as like Amazon S3 or Google Cloud Storage, API even services similar to Twitter or Facebook or Google Maps or Last.fm or whatever services that provide API, and also like caching systems like Memcached and Redis, for example. So these are examples of backing services that our app might use. And as we can see in this diagram, and as I mentioned just a couple of seconds ago, the 12 factor app does not care about where the service lives. Okay, as long as it knows how to connect to it. So we can see on the diagram on the right here that our app connects to a MySQL database server, has an outbound email service that it uses to send out emails to its users, for example, and it also connects to Amazon S3 to store its files. It doesn't really matter where these services live. They could be in the same country where the app is being deployed, or in another country, or like totally like on the other half of the world. What this app cares about is that it has this, I'm not sure if it's very clear in the video, but you can see on these arrows here, like what we call a connection string. And it's basically a string similar to the one we used last session to connect to Postgres, that has the information needed by the app to be able to connect to this resource. So in this case, for MySQL, it needs like a host name, a port, a username, and a database name and a password, for example. For the email service, it needs like some credentials, also like a username and a password, and like a from email that it uses to communicate with the server. For S3, it needs also like a bucket name or some credentials and a host or region, for example, to be able to connect to it. So these services, as I mentioned, could be running somewhere or could be running on the same machine. So for example, if we're working on our local machines during development, we can have like some similar services that the app can use. For example, Postgres instead of MySQL, we can have like a local like email service running on our machine, or even like a fake email service or an email simulator to test our apps. to test like the feature of sending emails locally without actually sending them. We could just use our disks to store files, but in production use Amazon S3. So again, and I'm re-emphasizing on this point here that the app does not care about where the service lives, it just cares about connecting to it. And each service, to be able to connect to it, we need to have this connection string, or what we call the URL, or like resource locator and credentials. And most probably these credentials will be stored in the config, that being like in environment variables or configuration files. And just a quick reminder from the config factor that we discussed before, most probably this is going to be a set of environment variables that are passed to our app that contain the credentials and the URL of the resources that the app needs to connect to. So that's quickly what backing services are. One other thing related to it that actually introduces us to the next factor, which is port binding, is that even our app needs to act as a third-party service or as like a backing service, because we might be building like our production app might be some sort of an API that we are providing to our customers or our developers, and then if they want to connect to it, they also need to be able to do this connection using like a connection string, which means that our apps needs to be running as a server somewhere, and they should be accessible over the network. Okay. And in order to be able to access something on the network, we need it to be bound to a certain port, because if you have worked with servers before, in order to be able to connect a server, to connect to a server, regardless what kind of service the server provides, you need to have like an IP or a host where the server lives, which is like an address, similar to like having a postal code or a post box address that people can reach you through. You need also to have a port, which is just a number indicating where exactly on that host you should connect to be able to connect to the service or communicate with the service, because a host can have multiple services running on it, each binding to us like to its own port. So in order to be able to connect to a specific service, you need to know first the address of the host, and second the port where this service is running on or living or listening on. And if our app is going to be acting as a backing service, it needs to be following the same like rules. It needs to have its own port to which it's being bound. And so let me introduce like a couple of vocabulary that we use when it comes to port binding. The first one, which is a port, which I just discussed, and it's part of this thing that we call the IP sockets or Internet Protocol sockets. And there's also the concept of Unix sockets. And first, let's discuss what an IP socket is. This is the commonly used way to communicate with the service. Because an IP socket usually has two attributes to it. It has a host and it has a port, which are what I just discussed like a couple of seconds ago. And this is the way that other apps can use my service over the network, because it's defined usually by TCP/IP sockets, which define how the network works. So in order to be able to talk to a service that lives like somewhere over the network, we need to have its IP, which is short for Internet Protocol, or like IP address, Internet Protocol address, which is basically like your street address, for example, and building number where you live. We also need to have the port, as I mentioned before, which is where the service is living on the host we're trying to reach, and then we'll be able to connect to the service. And in case the service is running on our machines, like on our local machines where our app is running, we can use this like sudo or loopback IP address, which is 127.0.0.1, which is usually referred to as localhost. And then we would basically be rerouting traffic from our machines and back to our machines in case we have all of the services running on the same machine. So we don't have to figure out what IP to use in order to be able to connect to services running locally. We just use localhost or 127.0.0.1 point 1 and provide whatever port the service is running on. So this is the commonly known way that is used to connect to services over the network. The alternative is using what we call Unix sockets. And Unix sockets only work if the services are running on the same machine. And how they simply work is that like the different services can communicate with each other using files. And what I mean by files is that a Unix socket can be represented as a file on our machine, on the hard disk of the machine. And for service A to communicate with service B, what happens is that service A writes its command to the file, to this like Unix socket file. And then service B reads this command from the file, does some processing, then writes back its response to the same file, and then service A would be able to read or receive this response by reading back the contents of the file. So it's basically like sharing a file between two services in order to be able to allow for this kind of communication. And this kind of communication is what we refer to by inter-process communication. So a quick comparison between using IP sockets or ports versus using Unix sockets is that Unix sockets or Unix domain sockets are running on the same system, which means that there's no overhead of going through the network to transmit information, which translates to this kind of communication being faster and lighter than using IP sockets and pushing traffic outside of the machine onto the network. So generally, if you're planning on running services or processes on the same host, it's usually advised to use Unix sockets instead of IP sockets, because you're, as I mentioned, getting rid of the overhead of pushing traffic onto the network, onto the outside world. And the drawback of using Unix sockets, in case, for example, you're using a package or an app that natively only runs on Unix sockets, is that you have to like add to it like a web server while you're packaging it to the outside world in case you want to publish it as a backing service. And this web server will be only responsible for translating or relaying traffic from the outside world using IP sockets to the Unix socket. And to briefly simplify that, in case we have a server running using Python, for example, so Python by default binds like one of its web frameworks binds to a Unix socket, and in order to be able to publish this app you're building using Python to the outside world, you need to also install or add like a dependency to your app, which is a web server. In case of Python, maybe like a web server called Tornado. And the sole purpose of this web server would be to receive traffic from the outside world on a certain IP and port. Then, as I mentioned, transmit or relay this traffic to the Unix socket that is being used by your Python app. And then whatever your Python app writes back to the socket, the web server reads it and then transmits it back using the IP protocol or the IP sockets or the network again. So this is the drawback of using Unix sockets. And as I mentioned, sometimes you're forced to use it if it's the only way provided by the tool you're using to build your app. But most of the time, the tools you use or the frameworks you use provide like alternative ways to communicate with them, either using like sockets or using IP addresses or IP sockets. So you will be free to use whichever way to build your app with, depending on your needs, of course. Okay, so this brings us to a new tool that I wanted to discuss this time, which is called Docker Compose. So if you remember from the last session, we were building a small Go app that communicates with the Postgres server. And in order for our app to work, we needed to first run the Postgres server, and we used Docker run, the command Docker run to run an instance of the Postgres server on our machines before we were able to run our app or read data from the server. But think of this. Imagine if our service started to have multiple backing services bound to it that it needs. So instead of having just a Postgres service, as I mentioned in the diagram here, We need like a database server, an email server, and a storage server, and so on and so forth. It becomes a little bit tedious to have to worry about running these services individually using the Docker run command before running our actual app. And this is where Docker Compose comes in. So Docker Compose is basically an orchestration tool, and what I mean by orchestration is that it acts like a maestro that orchestrates like the orchestra in this case, and it has the like the steps needed to be able to run our app. And those steps include not just building and running our app only, but also starting the services needed by our app. And so basically, a Docker Compose command would start whatever backing services our app needs, prepare whatever like environment variables or volumes or whatever like dependencies that are needed by our app, and then it builds and runs our app and provide to it like whatever information it needs to be able to connect to these services. So it's basically like a one tool that does everything for us, and this is why it's very handy to use it whenever we're working, especially locally. In case we need to have an environment up and running quickly, we can just issue a Docker Compose command that does all of the setup for us and has our app ready for us to work on. So as it's mentioned here, like Docker Compose is a tool for defining and running multi-container Docker applications, and multi-container is another word for having multiple services running, like multiple Docker containers running on our machine. It uses YAML to configure the different services, and as I mentioned, it has a single command that does everything for us. So an example of how a Docker Compose file might look like. So the file is called docker-compose.yml, short for YAML. First off, it has like a version which defines like what kind of specification this Docker Compose file follows. There are multiple versions. I guess the latest one is 3.7, but I prefer using 2.1 for a specific purpose that I'll be demonstrating in the demo in a couple of seconds. And underneath this version, we start defining the different services that compose our app. And one of these services is our actual app. So as you can see here, we say that we have a service called app that Docker Compose needs to build using dot. And what I mean by dot here is just the location where the Docker file of this app exists. And then I say that this app service depends on another service that is called DB, and then this DB service is defined over here. It's just a container running the Docker image coming from Postgres with the tag Alpine. So this is the Postgres server, similar to the one we used in the last session, and then it instructs this container to run with these environment variables. So like the Postgres user, root, the password secret, and the DB app. And then it tells it to expose port 5432 so that we are able to access it from the outside world using our browser, like our machine. So this is exactly similar to what we did in the past session, except that instead of doing it using the command line, we define it here in the docker compose.yml like file. So we don't have to rerun the Docker command every time and have to remember what kind of flags or parameters we need or arguments we need to pass to it for it to work. So again, this basically tells Docker, please create this DB service using the Postgres Alpine command with these environment variables, expose it on this port, and then run our app. And you can build it using the Docker file present in this directory, which is the current directory. And then our app will be up and running as we expect it to be. Okay, so this is the theory for it. Let's dive into the exciting part, a demo. So in this demo, I will be showing how to write like a Docker Compose file. So for those of you who haven't attended the previous session, you can find all of the files that we did in this repo here and the files of the coming sessions as well. Just go to github.com/ramino/12-factor-apps and you will find the code for all of the previous sessions as well as this session. But let's follow with me here and and take this one step at a time. Okay, so in this demo, I'm using the files from the previous session where we had a main.go file that basically just connects to a Postgres server using some environment variables that it loads from the environment, and it issues like a select query from a table called users, then prints out whatever rows or results it gets back. So it prints like the ID and the name of the users that exist in this table. Okay, and this is how it does the loading from the environment, from these environment variables that we can see that are prefixed with a db underscore. Okay, we also have this dump.sql file that basically has the instructions or the commands to create this users table that we just spoke about and insert some sample data into it. And we also have a Docker file, in this case a multi-stage Docker file. In case you can't remember what that is, refer to like the previous session about Docker where we discussed this. So basically this like builds the image for our app by including like the dependencies, copying the files inside of it, building it, and running it. Okay, so this is the Docker file that instructs Docker on how to build and run our app. Okay, so what we're gonna add now is a new file which is called docker compose.yml. And as I mentioned, the Docker Compose file, let me collapse the start part to give us more space. So a Docker Compose file needs to have a version at the top here. So I'll give it version 2.1 as I mentioned. You can use version 3.1 if you want, but you'll be missing out on a feature that I'll be discussing in a couple of seconds. So I'm using 2.1 for now. Then we start defining the services. The first one should be our app. And this app should be built using the Docker file existing in the current directory, which is referred to with a dot, as I'm doing here. So let's keep it like that for now. We also need another service that is called db, and actually this can be like whatever name you want. We can just call it db, we can call it Postgres, we can call it whatever, but I usually just call it db. Okay, and this db service will run from an image that is called Postgres with the tag alpine. It needs some environment variables, so I'm going to pass to it this environment key and tell it that we have a couple of environment variables that we need. And remember, these we got them from Docker Hub. So let me do that again. Docker Postgres. The reason why I'm opening this page again, I know I did it last time, but there's an extra thing that I want to show you here. So first let's copy the environment variables from the bottom, where it defines like what user we want to create, what password we want to use, and the name of the database that we want to create as well. Okay, so let me align these and provide some values. So the user is going to be root, the password is going to be secret, and the database name is going to be app. Okay, one last thing we want is to expose port 5432 from the container to the outside world for us to be able to access it like from our machines directly in case we need to debug or something. Okay, so now we have the services defined. Next we need to define the dependency between these services, and this can be done by using this depends on key, and we can just say that our app depends on db. Okay, so let me save the file here and try to run it. So we say docker compose up, and what this command does is that it starts the services for us using the configuration that we have in the file here. So let's run it and see what it does for us. So we can see it created like the db container using the configuration we set. It created the app container using also the configuration we set, and it started printing out the logs for both containers. And we can see like at the lines are prefixed with the name of the container to help us like know exactly where the logs came from. So here we can see that there's a problem with like with our app, because it cannot find like the driver that it should use to be able to connect to the database. And the reason for that is that our app, as I mentioned, it needs some environment variables to be set for it to operate. And we haven't defined these environment variables yet in the Docker Compose file, so let me do that. We just say here environment, similar to what we did with the DB image below. We paste them in, and then we specify some values. So for the driver, it's going to be Postgres. For the host, let's keep that a little bit. For the port, it's going to be 5432. The username is going to be the same one we use down here. The password is also the same, and the database name is also the same. Okay, so for the hosts, someone starting to use Docker Compose will just type localhost, because this is what he or she is expecting the database server to be running on. Okay. The thing is, Docker Compose handles hosts in a different way. Like if we're running using the docker run command, or we have Postgres installed on our machines, we can directly use localhost, because this is where the services are being bound to. But if we're using Docker Compose, there is a bit of a difference that we need to take care of. And the difference here is that Docker Compose not just creates containers for our apps, but it also, let me try to show here. Okay, let me first clean this up a bit, because I ran this command before I started the demo here, so there's something missing from this logs. So let me try to run it again, and I'm passing this -- build to force it to rebuild the the Docker image for our app, just to show you like the full logs from when you first run this command, like on a clean environment. Let me hit enter. So we can see here the first thing that it does is that it creates a network. And what it means by this network is that it creates like a small virtual network between the different services that are defined inside of this Docker Compose file, so that whatever services are running inside of this network can see each other, but they're not exposed to the outside world. And this is very beneficial if you have multiple Docker Compose files or Docker Compose commands running on the same machine, in case they share, like they have similar databases, for example, Postgres, and all of these databases expose the same port. Then you won't be facing a problem if you run them on the same machine, because each Docker Compose file is ran inside of its own virtual network. So no conflicts will happen on the ports, because I haven't mentioned that before, but we cannot have multiple services bind to the same port. Okay, so this is a very good thing that Docker Compose does for us. And the only drawback for this is that we cannot use localhost anymore. We have to use a special kind of host name that Docker Compose makes available for us to be able to communicate to the services running in the same Docker Compose environment. Okay, so what this host name is simply the name of the service that we used here. So if we have DB, we can just specify DB as the host of the database server. Okay, is that clear? Cool. If it's not, just let me know in the comments, and I'll make sure to go through it again. Okay, so in case we have this DB as something else like Postgres, we can just use the same name that we specified here. Okay, but I'll keep it as DB for now. Okay, so now we have the environment variables defined by our, like inside of the Go file here. We have them defined in the Docker Compose file, and theoretically we should have everything ready for our app to run. Let me first show you here what happened like when we ran the Docker Compose up command. So it created the network, it then built the app using the Docker file provided, and this is similar to what happened when we used Docker build from the previous session. And after that, after it successfully built the app, We can see that it created a container for the database, it created a container for the app, it attached to both containers, and what it means by attaching is that it attaches to their standard output and standard error so that it's able to print out the logs from these containers. And then we can see the logs from the DB server and also the logs from the app. Okay, this is still showing an error because we ran this before like updating the environment entries in the Docker Compose file. So let me stop this. And we can use the docker compose down -v command to totally bring down our like our docker compose environment. And -v means that if we have volumes, and I'll be speaking about volumes in a couple of seconds, if we have volumes, also please delete these volumes, so that we're like totally clearing out like any resources that were created by docker compose up. So let me bring everything down and then up again. We don't have to pass the --build flag here because we don't want to rebuild the image. We might need to do that if we made changes to our main.go file, but we haven't. So let me just do docker compose file to avoid rebuilding the image again. And we can see it's recreating the network, running like the app container, the DB container, and then the app container. We can see the logs from the DB here. And we can see here that like the app was still not able to connect to the server. And the problem here is that it tried to connect to it, as we can see, before the database actually finished initializing, because we can see the logs from the DB are still continuing to be printed out, and it's only here where it says that the database system is ready to accept connections. So apparently this depends on command doesn't work in the way we expect it to work. And this brings us to something that I want to talk about when it comes to services, and it's called service health. And what I mean by service health is that a service goes into two stages from when Docker Compose starts it. It goes first into a ready state, where the start command of the app or the service has been run already, and then it goes into a ready state, which is when this service is ready to accept commands from the outside world. Okay, so in this case, the DB service here goes into like a ready state when Docker Compose hits like its entry point from its Docker file, but then it takes some time, as we can see, with all of these logs being printed, for it to reach the state where it's actually ready to receive connections. The thing is, now we don't want our app to try to connect to this Postgres server unless it's ready to receive connection, which means we need to wait for it to be ready and not just like started for us to be able to communicate with it. Okay, and to do that, this is why I mentioned we need version 2.1 of this Docker Compose file, because later versions do not support this feature. So what we can do here is that we can tell the app service that it depends on DB, but not just depends on it being started. It needs to also let me remember what the command was here. So this is basically called docker health check. I always keep on forgetting like the syntax for it. Docker health service healthy. What I mean by healthy is that it's ready to receive connections and so on. So to do that, we tell it, let me quickly grab, why is it always so hard to find what I'm looking for during demo times? Yeah, you know, I can just get it from like what I prepared in the session from before. Yeah, it's this part, exactly. So condition service healthy, okay? We just add this line here, and this instructs Docker Compose to wait a little bit before starting our app and only start it when this DB service is healthy, okay? But this feature here is like a two-step thing. So first we need to define this condition, but we also need to have like an extra step in the Docker file of this image, the Postgres Alpine image, that states or defines what is meant by healthy for this service. So how do we know that this service is healthy? And in this case, it should wait until the database tells it that it's ready to receive connections, as we saw in the logs here. So we can either define that manually inside of the Docker file, but we only have access to the Docker file of this if this service is something that we created. But in this case, Postgres Alpine is not something owned by us, so we can look for an alternative image that has this health check defined. And thankfully, there's someone out there that created this. We can just type health check Postgres Docker. And we can see that there's this image here called health check slash Postgres that is just a copy from the Docker file of Postgres, but it also has like the extra line of the health check. And I can show you this here actually, just not to get you so confused. So if you go to the GitHub repo of this library, it actually supports multiple services, not just Postgres, so it might be useful in case you use any of these other services, but let's just check Postgres for now. So we can see that for the Docker file.alpine, it gets the image from Postgres Alpine, but it also adds this health check command, which basically just runs this Docker health check command. And this Docker health check command is just like a bash script that we can see over here, which just waits on like the Postgres port provided in the configuration until it's up and ready to receive connections. Okay, so this is in case you need to define your own health check in your own service, but for us we don't really care about this command. All we care about is just to use this image that has the health check command. Okay, and we can do that by just prepending health check slash here to the image name, and we can keep everything else as is. Okay, so let's try that out. If I drop this and then hit Docker Compose up again, maybe hit down first to clean everything out and then try up again, we'll see that now it takes some time while it's creating the session DB container, because now, like before it creates the container for our app, it waits a little bit because now it's waiting for the DB server to be initialized and ready to receive connections. So let's wait a bit. Let's wait a bit for it to finish. It usually takes some time because the server takes some time to run. So anytime now. Yeah. So we can see now that after it waited, it created the app here, and now our app prints out that the relation users does not exist instead of saying that it cannot connect to the server, which means that it was able to connect to the server, but now we are facing another problem, which is that the database server that got created is totally empty. It does not have this users table or relation inside of it, and that's why it's complaining here. But the good thing is that we now are sure that the app will only run when the DB is like the DB service is ready to receive connections. Okay, so let's tackle this other part here where we need to run. Remember from the past time, like the previous time, we needed to run this, like the contents of this dump.sql file, so that we have the users table created. We need to find like a similar way to do it, but using Docker Compose. And to do that, this is the reason why I wanted to keep like the Postgres document, like image documentation page open, because at the end we can see that it mentions something about init scripts for the database. Let me scroll to this. I guess it's a little bit, yeah, initialization scripts. And what this is that there is a certain directory inside of the Docker, like Postgres container, that is called /docker-entry point-initdb.d. And this directory is empty initially, but if we create any files inside of it that either have the .sh extension or the .sql extension, okay, these files are going to be executed after the server is ready to receive connections and before telling the world that the server is ready to receive connection, which means that when we are initializing the server, these scripts will be run to make sure that like the contents of the database are ready for us to consume, and then it will publish the healthy state to other services to notify them that now it's ready to receive connections from them. Okay. So basically, if we create a file inside of this directory with the contents of our dump SQL, we will make sure that the users table is created and populated before we connect to it. And to do that, so how can we modify the contents of this Docker container? We can use like one feature inside of Docker Compose and Docker, which is called volumes. Okay, and what volumes is, it's just telling Docker Compose that we need to mount a directory from our machine inside of the Docker container. So in this case, we want to mount this dump SQL file, and we can just say that this dump SQL file is present in the current directory, and it's called dump.sql, and we want to mount it inside of the container. So we use the colon and then provide the path inside of the container where we want this file to be mounted. So we can just copy this from here, paste it here, and then use the same name. Okay, so basically we're telling Docker Compose here, please include this file inside of the container under this path. Okay, so now if we can go into the container and check the file system of it, we will see that this file exists with the content of the file that we have on our local machine. Okay, so if we save this here, hit Control-C, and rerun the Docker Compose app command, but let me pass app to it because now I wanted to just print out the logs of the app service. I don't want to worry about the logs of the database, and I hit enter again. It says recreating the DB container because we made some changes to it. It waits a little bit for the health check to go through, and it should run the SQL file that we attached as a volume, run it as a part of its initialization, so that the users table is available for us to query. And once that file is run and the server is ready to receive connections, it should create our app, and it still says that the users table does not exist. Why is that? Let me double check that nothing went wrong. So maybe I need to first bring down the app because I need to clear the previous stuff that were made. We made changes to the Docker Compose file. So let me bring it down and up again, and let me print everything out. Just I want to show you where exactly it reads the file, and also to make sure that it actually reads it. So let's wait again. Yeah, you know, it's always a problem with the demos that they crash when they are being live. Like it's part of being a software engineer that you can never have a fully working demo. But let's hope it works now. So now again, it's creating the container, initializing the database, and hopefully executing the contents of the SQL file that we provided. And okay, so apparently there's a problem here. Okay, so here it said that it dropped the table, it created it, and it inserted the records into it. But then something, so it turned it down. Oh, it worked. Okay, so yeah, so apparently we just needed to like bring down the setup that we had because it was cached from the previous time we ran it before we added the volume. So let me do that again. Rerun up, but with only app to only see the output of the app. And yeah, the problem with health checks is that it takes some time to run it. There are some other ways to do it, but I found this to be like the most straightforward way. For example, you can add like a loop inside of your code that checks if the port, like the DB is available on the port or not, which is basically similar to what the health check script is doing, but instead you're doing it inside of your code. And you can actually do this in case there is no health check image for the service available out there. And then after the connection is made, you continue on with the logic of your app. But I found it to be like pretty straightforward to just use an image from the health check like repo as I showed you here. And we can see that now the app is able to read the data that was injected or initialized inside of, like during the initialization of the Postgres server. Okay, so again, let's quickly go through the Docker Compose file. We can see that here we defined how the app service works. We provided like it with environment variables and its dependencies, and we spoke about like the difference between ready and live, like ready and healthy, or started and ready. They're like a different set of terminology depending on what systems you're using. And then we also defined the DB service here from the health check repo, gave it some set of environment variables, told it which port to be exposed on, and then we defined like this initialization script as a volume. We mounted it as a volume. One last thing I want to mention is that this port bit here is not needed unless you want to access the like the service from your machine. Let's say you have a Postgres client installed in your machine and you want to connect to the Postgres server or database that was created inside of this Docker Compose environment. So you need to expose the port as shown here. But if you don't want to and you just want this DB service to be available to other services like the app service here, you don't need to include this port because, as I mentioned, Docker creates a network, like a virtual network between the services, and all of the ports are exposed inside of this network, so any service can access any other service. And yeah, so you don't need to include this unless you want to connect to this DB server explicitly. Cool. Okay, so this sums up what I have to say today about these factors. Let me go to the slides again. I guess this is the last one. As always, you will see the slides available in the link bit.ly/Romino-12 factor. If you go here, you will find the slides. I always update them before the session, so you get a chance to take a look at them before I start the live session. This should have like the latest version of the slides. Sometimes it's cached, so you need to like force refresh it to get the latest version of the slides. Let me know if that does not work for you, then maybe I can provide you with a PDF version of the slides in the same repo as well. You also have the code over here. We can see like the Docker Compose file we just created is over here with all of the different things that we added. So yeah, as always, thank you for staying till the end, for those of you who stayed, and I hope this session was useful. Let me know if you have any questions, either now or through like the social media, and yeah, until next time. So stay safe, stay home, and see you next time. Goodbye.